Okay, so we have done, so the steps of equation 1 and 2 is basically these steps over here. I should write this down before. Is we just did static analysis. Okay, so ABX minus ADX is equal to 0. Summation of forces in the vertical direction, positive is going up. So ABY minus ADY minus FAC is equal to 0. Okay, so we need to find out what is our ABX. Okay, so the angle, if we look at the angle, so what we have is 60 degrees and 45 degrees. So we know that this angle over here is 60, and we know this angle here is 45. Okay, so using equation number 1, right, using equation number 1, so ABX is FAB, right, FAB cos 60 minus or is equal to ADX, right? So ADX is equal to FAB, which is 18.925 times 10 to the power 3, and then we do a cos 60. So this is equal to 18.925 power 3 times by cos 60 is equal to 946.2.5, and then this is equal to Newton. Let me do it again. Cos 60 times by 18.925 power 3, 9462.5. So that is our ADX. Okay, so by knowing our ADX, so we have known what is our ADX. Okay, and we also know what is our ABX. Okay, so this is also equal to our ABX. Okay, so the next thing, if we look, okay, so using, so from equation number 2, right, by looking at equation number 2, we need to find what is our ABY and our ADY. Okay, which is straightforward now because we know our ABX, right, or FAB. So to find ABY, okay, we have to find ABY is equal to sine 60 which is equal to ABY divided by FAB, right? So this is very straightforward trigonometry. So ABY is equal to FAB sine 60. Okay, so FAB is equal to 18.925 times 10 to the power 3, and then we have sine 60. Okay, so 18.925 power 3 times by sine 60 is equal to 16.389 or 16.39 times 10 to the power 3 Newton. Okay, we have this. So the next one we're going to find is ADY. Okay, we have to find ADY. Okay, so we have to find ADY. So to determine ADY, because we know ADX, so we can use tangent 45 is equal to ADY over ADX, right? So tangent 45 is equal to 1, right? So you know that ADX is equal to ADY, right? So we have found what is our ADX, right? It's 9462.5 Newton, right? So we have all the expression already, right? We know our ABY, we know our ADY, right? So using, okay, equation number 2, so ABY, which is 16 point, let me not skip steps. Okay, so we have ABY minus by ADY minus by FAC is equal to 0, right? So FAC is equal to ABY minus by ADY. Okay. So ABY is equal to 16.39 times 10 to the power 3 plus by 9462.5. Okay, so this is equal to 16.39 power 3. Oh, sorry, minus, I do beg your pardon. Minus by 9462.5 is equal to 6.9275 times 10 to the power 3 Newton. Okay, and how to check whether your value is right or wrong? If this is positive, it's correct. If it's negative, start to panic. Okay, so 16.39 power 3 plus by or minus by 9462.5, you get 69275. Okay, that's your FAC. So by knowing for FAC, right, we know your FAC, so therefore the mass at point C is equal to 6.9275 times 10 to the power 3 divided by 9.81. Okay, so divided by 9.81, I get 706.17 kilogram. Okay, so the answer is 706.11. We are not that far away. Okay, so this is correct. So in terms of, if you ask me in terms of grading, how will I award marks? So to award the mark, this will be another 1. Okay, this is a 1, and then this is also a 1. Okay, there is also a 1, and then this number is also 1, and divide by 9.81 is a 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and 2 marks elsewhere. Okay, so this is how marks will be awarded. Okay, so again, let's say if this value is wrong, okay, so 9462.5 is wrong. Okay, what will happen? It will affect this number and will affect this number, so we will mark accordingly, like what I've shown you. Okay, any questions regarding the marking scheme or revision for centric buckling? Anyone, please?
I have a question just about like rounding.
Okay.
Like Do you want us to round to a certain number of like significant
Yeah,
figures or something?
okay. So in terms of let's say in terms of forces, okay, you will not. I mean, you will not be far off if you're rounding. Okay, but I have to be careful. In terms of forces, okay, if your answer is 923.1 Newton, okay, you can leave it at 923 Newton. It's fine. Okay, you can leave it at 923 Newton because if we look at 0.1 of a Newton, it's equal to how many kilogram? So 0.1 divided by 9.81 is equal to 0.04 kilogram. What is 0.04 kilogram? Sometimes it's difficult to measure. You get what I mean? So forces, you can put 923, it's fine. In terms of stress, okay, I want it to be three decimal points. So let's say you have 923.4, or your answer is 4579114, for example. Okay, and this is times 10 to the power 3 Pascal, for example. So I want this to be 923.458 times 10 to the power 3 Pascal. And all your units should be 10 to the power 3, 10 to the power 6, 10 to the power 9, or 10 to the power minus 3, 10 to the power minus 6, and 10 to the power minus 9. Are we clear? Okay. These engineering units, we don't do 10 to the power 7, we don't do 10 to the power 8. Okay. Is that a fair answer to your question? And also there's another one based on geometry. Geometry is also 3 decimal places. Okay, does that answer your question? I think this should be clear. So geometry is also like your second moment of area, I, your radius, anything that's geometry related, 3 decimal places, you should be fine. Okay.
Thank you.
Thank you. Okay. So now, so this is the question. If you were to look, I was just looking at the solution manual. They do things differently, but the outcome is the same. One thing I don't understand is how they get from the wrong second moment of area to get the right answer. That's where I don't understand. Okay, but that's why for the for the what for the wait for the solution provided, just check like these values are correct. That's the more, don't follow their step. Now there's another step for this question. Okay, that's where the 2 marks come in. The next thing, in Berkeley, you always have to do this. You always have to do a stress check. Okay, check on the stress of the buckling structure. Okay, we always have to do a stress check. Okay, so what we mean that we do a stress check? So the formula is critical stress is equal to P critical divided by area. Okay. So now, did we have this in our formula sheet? Okay, on our summary sheet, we realize we did not have it. Oh, we did not. I mean, we partially have this. So you also have to write here that this is equal to P critical divided by area. And then you put another point that I've just written, that you have always do a check on stress of the buckling structure. Okay, so this is your so-called your summary sheet, right? So you just put this in. Okay, so what you can see down here, a summary sheet is always what? Continuous improvement. Okay, it's not like you write one time, okay, we are good to go. It's always, you're always improving it based on when you have completed doing specific questions in your assignments. Okay, then you come over here Okay, we have to do our stress check. So this will be, so our P critical, what was it? Our P critical that we calculated is equal to